Good morning, ladies and gentlemen, and welcome to this event organized by the Global Policy Institute and Bay Atlantic University in Washington, D.C. My name is Paolo von Schirach. I serve as president of the Global Policy Institute and also as chair of Political Science and International Relations at the Bay Atlantic University of BAU. Again, we are downtown Washington, D.C. Today, we are going to listen to one of Europe's, and I would say probably more than Europe, global experts on all matters pertaining to rising sea levels and how coastal areas, and in particular lagoons, can and should deal with the challenges of our changing planet. It is no mystery, and many of you probably are aware of the fact that because of global warming and increased levels of CO2 that traps heat in the atmosphere, we are witnessing the phenomenon of the melting of glaciers. And then that means that more water, ice turning into water, adding to volume, and rising sea levels. While this may sound to many like a problem for tomorrow, that somebody else will have to deal with as a distant issue, unfortunately, it is not the case. It is quite real and happening now. Many communities around the world, whether it's in the United States, in Europe, in Africa, in Asia, whatever, are already busy trying to figure out practical solutions to save coastal areas from flooding. And Venice is definitely a very, very important hotspot in this respect because of its origins, and a city created on a lagoon and has always been threatened by high waters and high tides and what have you. But now, with the added problem of rising sea levels, what used to be a nuisance has turned into a crisis. And Giovanni Cecconi with us today has been and is right at the center of all this, of the debates, and then of the plans and solutions that have been put together over many years that now give Venice a brand new sort of set of solutions which are articulated, and he will explain what this is all about. Not just physical barriers, but also attempts to recreate the natural environment which should help preserve Venice, which is a patrimony of world cultural heritage, if nothing else, and of course a place where real people like you and I live and want to continue to live in decent conditions without having to have water at their knees or above for many times during the year. Anyway. With all that, I just wanted to say that we at GPI and BAU are really committed to exploring and finding out and analyzing best practices and ideas and novel solutions that help all of us, on this earth cope with the impact of global warming and hopefully devise methods to have, sustainable development models which are affordable, cost-effective, and good for all of us. And with that, I would like to turn it over to my good friend and colleague Massimo Ciarla, who will be kind enough to moderate this event. He will give maybe a more appropriate introduction to our speaker, and then Giovanni Cecconi will tell us Venice's story. Thank you. Massimo, over to you.
Thank you, Paolo. Thank you, Paolo, and welcome, and thank you, Giovanni Cecconi, for this event, to participate in this event on Venice Minnesota Square project and the MOSE project. So, Paolo just presented the great problem that we are facing today with these climate changes. And the Venice project is a coastal environmental engineering project that use use all the state-of-the-art integrated solution, and is observed and studied with a high very interest by several countries that are involved in searching solution for the mitigation and adaptation of the effect of the climate changes. This project will be presented by Giovanni Cecconi today, ago. And Giovanni was one of the first to be involved with the projects. And this time, I mean, a project that is not only based on the storm surge, I mean, barriers, but also based biostabilizing structures. And Giovanni, resilience in the lab, that is that daily would say. And it also is also promoting sustainable solutions for a coastal city in different parts of the world. Is in integrated natural-based solution for navigation, for fishing, for agriculture, and for also the ecotourism that is going to present, I mean, today too. And we said that, I mean, I would like to ask, I mean, Giovanni to start the presentation that, as I said, it will be not just based on the storm barriers, but it will be more the full project that includes, I mean, all the different, I mean, aspects of restoring the environment and reinforcing sandbars and with the coastal protection structures, and also improving the quality of the water that has been created, I mean, problems, I mean, by the industrial activities that have been taken place, I mean, in the south part, I mean, of the lagoon. With that, I will say just Giovanni, let's start your presentation and presenting this fantastic, I mean, projects. All the people that, I mean, they are the participants, I mean, of this event that would like to ask a question, please put your question in the Q&A section, and we will address this question at the end, I mean, of the Giovanni presentation. So Giovanni, please, you're on.
Thank you, Massimo. Thank you for this very kind invitation. It is a great honor and pleasure to me to be with you today to introduce you to the Venice experience in adaptation to sea level rise. Here you can see the title of my presentation and who I am, as Massimo has summarized. Our motto is borrow, blend, and serve. And I expect from today a nice borrowing and blending exercise for serving the world. Okay, Venice by itself is the history of co-evolution.
Giovanni, we lost your voice. You are on mute.
I was trying to remove the video because I cannot see the slide. Allora, nascondi. Okay, it's better I don't touch. So it is the history of coevolution. Coevolution is the competition and cooperation all together among water and land, the environment and the civil society, and the very secret of Venice rely onto this. And now we have to face conservation and development. Again, there must be a competition between the conservation and the development. Venice is a very complex system. It's a natural lagoon, it's an industrial harbor, it's an historical city, and it has been able to maintain for 1,600 years. This year, by the way, we are celebrating the birthday of Venice with great celebration. And if COVID will allow, you are invited to come and join our Resilience Lab, who will promote this international exchange of experience. Essentially, it started as a fish farming place. And in the 12th century, it was the logistical base for Europe to reach the Holy Land during the Crusade. That's why Venice is made of many islands with monastery, because the monk took care of the logistics. Also, it is a nice wetland system, and with plenty of barrier island who are protecting the lagoon. But if it was only by nature, the lagoon would have been siltated. The Venetians redirected the river out in order to maintain this unstable environment. Here you can see, before human intervention, the shift in the archaeological remains from Neolithic, Mesolithic, and Bronze Age due to the oscillation above in the main sea level. But then human entered the lagoon. They arrived because they were searching for food, hunting and cultivation, harvesting clams, fishing, fish farming, and then they had to cope with nature because the natural system was unstable. Here you can see the siltation of one of the three inlets separating the sea from the lagoon, and there is this shoal of sand that was accreting, and the fishermen that strive to earn their living at sea with the storm find the death just in front of the house because of the difficulty entering the harbor. You can see, in order to reach the harbor, you have to take this canal, so you have to look at certain post and follow the line, but then at a certain point you have to change the line with other belfry tower. Most of the time they ended up during the storm ashore and dead. So with this claim, with this speech, a mathematician in 1875 asked for installing a solution. Leonardo da Vinci studied the possibility to use the natural energy of nature, the tidal energy, to flush the sand away. And this was done, but only 50 years later. This intervention can resemble a very much impacting transformation. If you do an environmental impact assessment, maybe you fail in getting the authorization. But at that time, there was no VIA regulation, and the work was done. And if we look now at the consequences of this huge transformation, imagine to reduce the tidal inlet to 1/3, installing this huge inlet breakwater in order to concentrate the tidal current, make it quicker, faster, in order to scour the sand below. Bene, then what has happened? Here you can see the site of the construction of the inlet breakwaters in this location. And we had a very long discussion in installing the navigation lock to enter the lagoon when the barrier are closed in this location, because they are close to one of the most renowned natural area that is protected by European regulation. So the end house of that previous transformation is this magnificent dunes park in which there are many species and biodiversity. Now, my question to you is why humans are able to trigger such amazing natural transformation? The answer is based on two constraints, two positive outcomes. First of all, availability of space. When you interact with nature, you have to give nature the space to grow. In here, there are plenty of space. In fact, this pocket trapped the littoral drift, and the wave energy and wind energy piled up the sand, and then the sun started to grow the Ammophila, that is a special plant that is stabilizing the sand in the dune system. So the space is a constraint that in this case was well respected. And then you need time. You cannot, if you allow nature to take its own time, its own pace, and build up, these species are very smart, are selected during their evolutionary history to engineer the landscape in order to make it more viable for their living in terms of food, in terms of stability. So essentially, these species are natural engineers, and we can cooperate with them. So another important aspect I want to stress is the landscape you see at the very wide scale start at the microscopic interactions among the sand, millimeter size, and among cyanobacteria and other organisms that provide stability to the sand, as it is the case in this footprint. Again, this is a shelter, and in this shelter you have a protection in which you can trap the nutrients and the seeds, and then in the following year you have the best melting pot to have the Ammophila, to have the allophytic vegetation that lives into the brackish water to start growing. We published this understanding of how nature is working in a publication here. You can see in International Journal of Design and Nature Ecodynamics, together with Professor Tiezzi. And we called this behavior cause confined ontic. Ontic is the capability to preserve itself without awareness. Open, you must be open to the flow of energy and matter systems. And these systems are able to pump order out of chaos. So they are providing a well-structured and fruitful environment. But Venice is also a place in which we have the mass tourism. And before COVID, we had a very serious problem coping with this flood of people entering the city with the huge ships. This is because humans forgot about the equilibrium with nature. So now we want to exploit nature in a very short time, to be in Venice in just one day, half a day, in half an hour to commute from the airport to San Marco, and then go into our magnificent cruise ship and continue to travel in the Mediterranean. This is not a co-evolution or co-evolution between the society and the nature, because as you well remember, in order to be fruitful, this cooperation needs space and time. Instead, here, everything is concentrated. And so that's why it is a negative impact. Whatever you do, the impact remains because we want to travel faster. And this is the problem. why not transform the time of travel into an opportunity? This is how nature is working. For nature, there is no dead time. Nature is continuously active to maintain its possibility to survive. And so we have to behave. Sea level rise is another challenge. Here you can see Trieste and Venice. Trieste is in a rocky area, so it's very stable, not affected by subsidence. That is the squeezing of the soil due to tectonic motion and to compaction. Instead, Venice is a weak soil, Trieste and hard soil. And so you can see that in Venice, the sea level is rising twice as fast as in Trieste. And at the moment, we had during the last 20 years, a jump in the order, I try to point out, let's see if it works. The pointer, let's see, no, I'm not sure. But we had the jump, you can see maybe my cursor, of 15 centimeter from 23 to 35. All over Italy, the problem of sea level rise is very big, and the area in red will disappear with the sea level rise of 1 meter. So this means all the areas from Ravenna till Grado. The flooding is more and more frequent, and more the city is flooded with an higher water. Here you can see the duration of the flooding from the beginning of the century. So it has been amplified by a factor of 20, and also the surface that is impacted. The Venice solution is a combination of engineering nature and learning and building with nature essentially, and mobile structure coupled with local protection. So we are raising the bank of the city as much as we can in order to maintain the city open. Do you remember the openness of the course? If we close too much, the city is not working. So we need to keep the city open, but at the same time, we need to keep it protected, so confined in a way. And the confinement is provided by the flood barrier. So again, the flood barrier and the local protection is the proper balance between openness and closure. And this is associated with a huge reuse of sediment, sandy sediment at sea to protect the beaches, and muddy sediment inside the lagoon to construct salt marshes. This is the general scheme of intervention, so a combination of a mobile barrier, coastal protection, local protection, the safeguard of the polluted upside of the past, and the local protection of historical island. Till now, 56 kilometers has been protected of littoral with more than 8 million cubic meters of sand, 12 kilometers of dune, artificial dune with rain planting of Ammophila has been reinstalled, and also the inlet breakwaters has been armored for a total span of 11 kilometers. Just to give you an example, we are speaking about a project in the order of 12 billion euro. Katrina required 36 billion euro, most of them to build dikes and levees. But of course, the size of the Delta of the Mississippi is 10 times the size of Venice. So, and the subsidence of the New Orleans is much higher than the subsidence of Venice. At a certain point, we have to think about if adaptation and resilience is the solution, or if we have to retreat. It will depend on us. If we are unable to stop sea level rise with a better sequestration of CO2 and change the composition of the atmosphere in our advantage, in our favor, then maybe we can continue to strive on the coastline. Otherwise, we have to consider to retreat. For now, because we do not have any more subsidence because we stopped the extraction of the water in Venice in 1970, we can afford this solution, that is to install an artificial beach that is protected by groins and submerged breakwaters in front of the seawall in order to reduce the impact of the wave. But if sea level is going to rise, let's say, half a meter, this beach will rapidly disappear because of the reflection of the wave of the energy against the seawall. Because this flexible solution is an added on top of rigid structure and cannot survive if you, even though it's well designed, if you change the environmental conditions. This is just to explain the limits of adaptation in case sea level rise is gonna rise at a speed that was not experimented before. Other solution refers to the reconstruction of salt marshes, reusing the dredged material for the maintenance of the harbor and the navigation channels. I want to come back to here because the similar solution is in place in Galveston, Texas. And now in Galveston, my colleagues are considering to install a big, in the Ike Canal, a big storm surge barrier as it is done here in Venice. And we shared experience with them, and it was very interesting because for us it was a way to go back 30 years when we were in the very beginning considering, envisioning this future of a protected lagoon. And now looking at them doing the first steps, trying to raise the consensus with public participation, indeed, for us, is a way to rejuvenate ourselves. So please come again and visit us, and we are more than eager to share with you our experience, because this is very much triggering our enthusiasm in what we are doing here in a peer review fashion. So salt marshes, I said, also 39 kilometers of armoring of salt marshes, similar to what you do in the Mississippi River with the delta with the Christmas tree branches or oyster reef, this kind of activities that are important, not only because we help nature to help ourselves, but because we develop a community. The people can do that kind of job by their bare hands with small boats, and in this way to stay connected. Another important attribute of adaptation is interconnectivity. And interconnectivity is fundamental for resilience, because if something happens, there will be a citizen that will ring the bell and everybody will come, and sharing the solution and sharing the experience, the problem will be solved. Instead, if you have a centralized system of supervision and control, at a certain point, the unexpected comes and the system will fail because there will be nobody on alert at that moment. So it is very important, the circulation of knowledge and the awareness, and this can be done only if you are able to pay for connectivity. But how to pay for connectivity? This is the purpose of May Lab, to create a connectivity machine that keeps the people connected in any way possible, in any possible way. These are the evolution of the salt marshes, the different scheme. I rushed here because this will be another lesson when we do next time. Just to show you the environment and how nature like this neo-formation environment. Immediately, if you do send the position in the middle of the lagoon at the intertidal level, oyster catcher comes nesting. We have more 300 terns nesting each year, just 300 meters from the historical city you see in this picture below. And this is the oyster catcher. There are at least 20 couples, and they regularly come over the last 10 years. And the age of this system is only 10-year old. You can see how it was done. Just an armoring with gabions. Gabions were deployed by this inner canal. Here you have to see that the canal was dredged internally in order to make stronger the edge that is facing the motorboat, the waves, and away from the wind. And then we fill this area with the sand from the foundation, the excavation of the foundation of the barriers. Similar activities. We developed a special gabion made by geosynthetic and small stones or oyster. This is in which you can see the historical pond for keeping the juvenile that are sold, that will be sold to the fishing farmers. This activity dates since the 1500. So what we did was to restore the edge of this salt marsh, guesting the fish farm, the fish pond with new land in front. This is instead the reclamation of the industrial area that were polluting the lagoon because of the lack of confining wall. Here you can see an example of a bauxite deposit with polluted with mercury that was stabilized with this sheet piling. Local protection. These are very important because if we want to protect Venice with mobile barrier, we have to close almost every day. So this is not viable because of the impact of navigation and because of the cost of the operation. So at that point, it would be much more convenient to close Venice inside the ring and allow the tide to enter in and out the lagoon. But before reaching that time, that maybe will come in 1 century, we are able to stop sea level rise due to global warming, or just in 40 years, if we do nothing, we have to live with this kind of solution. That is local protection. 100 kilometers of embankment has been elevated by 10, 20, 30 centimeters. Also, San Marco Square now has been delayed because of architectural reason and authorization. And now, in the beginning, we thought to this kind of solution to avoid the seepage of the water from the drains from the ground or overtopping of the bank, just to modify the elevation of the square, rising this area, and installing a bentonite geomembrane all over the square, kind of an inverted pool. But the interaction with the marble was so big that the superintendent of the fine art decided not to go ahead with this solution. So the present solution is to intercept all the conduits that are discharging the rainwater to the lagoon, but also importing the salt water inside the basilica, in front of the basilica. In this area that is now flooded more than 200 times a year. Of course, we need to modify the slope of the pedestrian walkway to reach an elevation that is 10, 20 centimeters higher. There are special spots like here in this corner of the Duke Palace in which we have to install some steel or glass plate. And apart from this, what we will do will be to maintain the conduit and put some inflatable balloon into this restored conduit in order to automatically stop the external water from entering inside. The work was scheduled to start the 1st of February, a few days ago, but due to bureaucracy, they have not started yet. This is one of the tasks of the Venice Lab, to facilitate the understanding of the bureaucratical problem and the weak point with a better interdependency between the user and the provider in order to solve the problem as quick as possible. Chioggia is very interesting because it's been protected just on demand. So there was the change of the elevation of the pedestrian walkway, similar to what was done in Zwolle in Netherlands, in which the historical Roman city built on top of a sea wall has been protected by a modification of the slope and installing barriers just inside the house, because some of the house has been cut in two parts with these barriers in order to maintain safer the inner part of the inhabitants. Instead, in this case, we were lucky because we could install raise the pedestrian walkway and install two gates at these two extremes. So in this way, all the area is protected. This is the one of the gate. But this local solution are not infinite. At a certain point, you have a limit, because if you continue to raise the pedestrian walkway, you need to raise also the roof of the building. This means to demolish and build on top. As a famous archaeologist said, Venice has a tradition of building on top. You have to continue to demolish and build on top. But of course, not everybody agree with this of building on top. And Hammerman made a very, very strong criticism on National Geographic. You can read saying that the barrier is artificial, so we have to demolish and build on top. Of course, yes, very simple. But we are not in India, in which whatever is new is nice and is interesting because they are more spiritual than us. We need our articles, our memories around. We are different. So any culture has its own limitation. In our case, we don't like to build on top. And that's why we try to install the barrier. Let's look at this film if it's working. So I relax a little bit and then we restart.
Si vede? Non si vede, Giovanni?
Come non si vede?
But we can see it. We cannot see it.
Giovanni, can you please select the optimize for full screen video option?
Okay.
No, we cannot see it.
It's better
we cannot
now?
see it. Is it's all gray.
Can you?
We can't see.
If, can you, excuse me, it is good quality or not? Because
We can't see it right now. We can hear it, but we can't see the video. Can you please select?
you cannot see the video.
No, can you please check the box
What you
optimize for
suggest?
full screen video?
Oh,
Like you did
I
before.
did it. Optimize per clip video.
Yeah, for
I
full
did that.
screen.
Full screen.
Yeah.
No, is not disability informazioni nascondi. Ottimizza per clip video.
Yeah, optimize for full screen video clip. Can you please check that box?
It's not available, this button here. Okay, we'll go. But essentially, I will stop this. Allora, come si fa qua?
We have to go back to the presentation.
Sì, andiamo qua. La presentazione qua. Okay, let's continue with the presentation because I have plenty of figures. So, and at the end, I will send you the YouTube or web address to see the video by yourself. Can you hear me now?
Yes, we do.
Okay,
Yes, we do.
thank you, thank you. So the solution is the installation of a mobile barrier at the free inlet separating the lagoon from the sea. Here you can see Lido entrance, Malamocco, and Chioggia. In Lido there are two canals, so there will be 21 gates, 20-meter wide in a depth of 6.5 meter, then 20 gates in San Nicolò, 12-meter depth. Malamocco is the deepest, minus 14 meter, because here is the navigation channel that goes to the industrial harbor. And there will be 19 gates. So this means that the width of this inlet is 380 meters. These are two inlets of 420, 400, and the Chioggia is a width of only 360 meters. So altogether it is a mile, 1.600 meters. 78 gates, 4 inlets. So this is the mobile infrastructure. Of course, when these barriers are closed, we have a full protection of the littoral that has been reinforced with beach nourishment and seawall. And also the river entering the lagoon has been redirected out. So Venice is kind of an atoll with all the doors that are closed, both from the watershed and the rivers and the sea. So if you want to install a similar device in Houston, in Galveston, or in New York, the main challenge is to provide the wall that is strong enough, because as the mayor of Venice said in the very beginning of the project, you cannot install a steel gate on a clay wall, on a fragile wall. And so the first priority is coastal protection, and then to think about mobile barriers. This is the lesson from Venice. And everybody was happy with the coastal protection, because every year the properties are in danger. The locks are located in Lido into this row, as I explained. You can see how close the historical city is to the northern inlet. This is Malamocco, in which there is the navigation lock. And this is causing only 2-hour delay when it will be finished for the ship to enter, even though the barrier are raised, are in position. In the beginning here, it was designed a very fast sliding door to open and closing the door in order to allow the ship to cross the lock very rapidly. But unfortunately, this door is not suitable, because here we have a lot of resonating waves producing a stable oscillation here, also because of the shape of this harbor. So this resonance destroyed the first sliding door that we installed. Now a second project on a rail is under construction, and it will be installed. At that point, we have another problem. This historical inlet breakwater that was maintained is causing difficulties for the ship to turn and align themselves to enter safely. And so the pilots are asking to demolish this one. These are the kind of constraints that we have here in Venice that are delaying the work, even though the work has been operated during the last 3 months, almost 20 times, avoiding the recurrent flooding with very great success, as I will explain later. But it is incomplete, of course, because of the bureaucracy, because of the constraints, because of our Italian attitude. But it is working, it is effective, as you can see in the CBS broadcasting that I will send you, I will distribute through the chatting line because we cannot see. So you have the witnessing of the functionality, even though imperfect, it is working. Maybe this is the secret of the flood barrier, an incredible solution for an impossible problem. Chioggia. The system is made of reinforced soil foundation made by concrete. It is precasted and then they are lowered into imposition from a dry dock that can be done above sea level or just in a bay that will be inundated later. The most critical mechanical aspect of the barrier is related to the hinge that has to allow the motion of the gate when from rest position to working position, and at the same time to allow the air to enter in order to raise the gate, and allow also the possibility to, with a twist lock, to disconnect the gate every 5 years for maintenance. This is how the gate is functioning. At rest, we start injecting air in this upper chamber. And when the momentum is in the order, is able to compensate the load of the gate at this 300 tons, the gate starts to rise. The pressure of the air reduce, and so the volume expand, and so there is an acceleration, and very rapidly, in few seconds, the barrier will emerge. Then, adding more air, the water can exit from an hollow at this end, and so the system can stay in position with the 3 meters at sea and 1 meter or less in the lagoon. When the operation are finished, it is enough to allow the air to exit inside the tunnel, and automatically the water will enter from this hollow that is continuously open without any mechanical device. So this system has no valve at all. All the valves are in the dry place inside the tunnel, and it will go down. Accelerated, and that's why there are dampers, as you can see. There are dampers to stop the falling. These are the dampers to stop the acceleration when it falls back. The solution was chosen among many other kind of gate, as you can see. We did more than 500 million of studies, investigation, and experiment during the first 20 years of the project. And this solution, for instance, with the intermediate piers, are cheaper but much more dangerous and not viable for Venice because of landscape limitation. In London, there were 2 accidents. They decided to have the same gap as the London Tower, that is 60-meter piers, every 60 meters. And they had 2 accidents. One was very bad because it was a dredger that collided against the pier. Rubber is also inexpensive, but for a so long span without piers, it's difficult to reach more than 150 meters, at least 20 years ago when we did these evaluations. Now maybe there are other kind of material that will allow this balloon to be operated in a more robust and resisting, long-lasting solution. This solution also is very interesting, similar to the Rotterdam system. This is a barge that is kept in the dry place aside, and brought into place just by removing the water and allowing the boat to to sail to the location. But in our case, in order to have a dry dock for the barge, we would have destroyed the historical fortress at the two sides of the entrance. Also, the weak point of this is it is good in place without waves. If you install it in place with waves, such as the Malamocco navigation lock experience, it will be put into motion, and the load is so big that when it will hit the bottom, it will destroy any kind of foundation you can figure out, like a big hammer. In fact, this has been applied in Rotterdam and other places in which there are not significant wave or long wave oscillations. This is Netherlands, in which the span is 40 meters because they have a motorway on top. So this was beneficial, was a win-win situation in which the landscape was not important, and they could exploit the piers also to make a bridge. And now they also installed turbine to make tidal energy. They have a very nice 5-6 meter tidal range. This is Greenwich, London, the Thames Barrier, the oldest. And in this case, the architect made the pier very nice, but they had two collisions, as I told you. And the maintenance is very cheap because they just turn the shield on top and paint it and put down again. The Rotterdam barrier, the size of 2 Tower Eiffel. The strong point of this solution is monolithic, so you have only two pieces, no waves, no landscape constraints, and you use it very rarely, only once every 10 years. If sea level will increase, maybe once every 5-7 years. Instead, in Venice, we are using 20-50 times a year, so a completely different. That's why our solution is modular, of small pieces that can be put into position in just 5 minutes. Instead, this barrier takes at least 3 hours to be put into position, and you have to close the harbor for the full day. When you close the Rotterdam harbor, you don't have navigation lock here. You lose 1% of the GDP of Netherlands. So it's a completely different barrier, even though it can look similar. So one aspect is the size and the shape of the steel structure. The other is the requirements and the operability of the structure according to the environmental condition. So I'm not saying that you have to use the MOSFET barrier. I'm saying that our solution was very challenging and not so simple if compared to these other barriers.
Giovanni, we should probably leave some time for questions. I mean,
yes. How many minutes I spoke?
So we have now another 5 minutes.
5 minutes. So I go. I go to the.
To the end. 5 minutes to the end, of the presentation.
Yes. Then how much time do we have for the discussion?
5 minutes.
So 5 minutes. So I another minute just to wrap up. And
okay.
So here you can see the barrier, how they are made, the monolithic casing that were transported over rails, and then to the lift, and from the lift to the water. This is what is inside the tunnels, the special hinge, male-female coupling. The first operation was done for the first 4. In 2013, I managed the rising of the operation on November 2014. Just incredible, it's 7 years ago. And now Here you will see on YouTube the film on the chat. The operation has been started the 3rd of November with the first testing, and it was decided to operate the barrier even though incomplete in a flexible way. The maintenance is very important. We have to decide if you keep it in Venice as a way to trigger the economical development of Venice, different for tourism, or to bring it far from the city. It's very controversial. But by the time the maintenance is suspended, and even though it was scheduled every 5 years, now it's 8 years that the barrier are below the water and need to be maintained. This is the control room. And the good news is the barrier can be operated in a modular way in order to flush the lagoon to avoid anoxia and for other environmental benefits. The handover of the barrier is expected to start 1st January 2022, so at the end of this year, to the new authority that I expect, if you sign my petition, will be ALMA, Agenzia Lagunare Magistrato alle Acque, to go back to the historical institution, Venice, over the last 1,600 years. Thank you.
Thank you, Giovanni, for this very, very comprehensive presentation of this project. That we see that, I mean, is not just the barriers, but include a lot of other structure that has been constructed in the lagoon and in coastal protection along, I mean, those breakwaters. One question that I could have, if I may, if you want to give us an overview of the principle and the factors that will affect, I mean, the full or the partial closing of the gates.
Can you repeat? Because I was reading a question on, was distracted.
So it said, just you want to give us an overview of the principle and the factors that will affect the full or the partial closing of the gates.
Essentially, we can use completely closing the full lagoon or use the hydraulic impedance. The flooding is modulated by the astronomical tide. So every 6 hours comes up and then goes down. This means that we can use the time of travel of the water and use a capacity of the lagoon in order to dump this wave. This can be done if we want to reduce the flooding of something like 15, 20 centimeters. We can close only the northern entrance. But if we need more than that, we have to close also the navigation channel that is 2 inlet out of 3. And if the storm is the first shot with very unpredictable winds, not seiching, in which it is easy because every 23 hours the Adriatic Sea is resonating, and so the superimposition of this seiching with astronomical tide give us the possibility to use 60% of the storm, the intermediate storm, the partial closure. And this is under discussion now in the newspaper. If you go into my web page, I am arguing with a professor in Padua that says that the barrier must be operated all together, because if not, it will be unsafe and dangerous to the lagoon. Yesterday, I was out in the lagoon to measure the impact of a partial closure, because at last, after many efforts, I succeeded in forcing the authority to test the partial closure. And they were very successful. No environmental effect, and also a good reduction of the water as expected, 17 centimeters, more than the 15 that is the minimum.
Oh, thank you. One question that I have from the participants is, what is the design life of the Venice Barrier?
The technical life of the barrier is 1 century. This was foreseen for a sea level rise in the order of 50-60 centimeters. If we are going to have 100 meters of sea level rise in the next century, this means that the technical life will be half, but the barrier will not be an economical failure, apart from the value of existence of Venice, because we have 50 years to find another solution, and it is the first advantage. And second, the cost of flooding over this next half-life of the technical barrier, the cost of this flooding is 2-3 times higher than the cost of flooding over a century, the avoided flooding, because of increasing sea level rise will increase the number of flooding exponentially.
During the presentation, you mentioned that the cost of the whole project was around $11 billion. Among the different structures that were built there, how much was the cost just for the barriers itself?
The barrier is 50%, 5.6 billion euro, not dollar. There is a 20% difference now.
In euro, right. And the rest, I mean, another 5 billion euro, just were all the reinforcing bars and the coastal protections and all the
Yes.
all the structure.
The other costs are related to, like in the Chesapeake Bay, pollution control from the watershed. It is also very cost expensive because it's the maintenance of the reclamation and the basin in order to avoid non-point pollution. Then there is the cost of securing the illegal dump site of the past. Then the cost to protect all the small island. This is not included in the barrier, the local protection. And the cost of reinforcing the littoral. Every year we have to put 10% of new sand because every 10 years the loss we have is 10%. This is a very low figure because our beach nourishment scheme is a protected beach nourishment. And so our sand lasts much longer than if you make a free nourishment without protection, stone protection.
Absolutely.
And then we have also the environmental restoration of the wetland, the dredging, the reuse of the mud, and the maintenance of the lagoon morphology, hydrodynamics, and capacity of biotreatment. Because the lagoon and the wetland can absorb the nutrients from the watershed if they exhibit a variety of morphological shapes, a variety of landscape. And this variety of landscape provides, as I tried to demonstrate, a variety of ecological services related to the biodiversity that we can introduce into the system. So if the lagoon gets flat and is transformed into a bay, we lose the morphological diversity that is able to support the ecological biodiversity. And then the ecosystem services. Most of the time, especially in the United States, these ecological values are not considered. When you, for instance, in Galveston, I could see the evaluation of the cost effectiveness, cost benefit of the different scheme. There is no computation of the value of the ecosystem services that you produce. And usually this is causing to waste sediments. You dump the sediment at sea because it's cheaper, but you don't consider the value for the ecosystem in bringing the sediment on shore and doing dunes or doing natural-based solutions.
Another, all these costs, I mean, yes, in these risk analysis are definitely, I mean, being done. And but one of the questions that we have also from the participant is, what is the operation and maintenance cost per year to operate these barriers?
It is in the order of 50 million for the barrier itself, including all the personnel, the painting, and maintenance and operation. And then we have another 50 million for maintaining the complementary structure. I explained the beach nourishment, the wetlands, the maintenance of the canal, and the maintenance of the delta in terms of phytodepredation. So altogether, also the dredging of the city, because the sand, the mud goes into the channel of the historical city in which there is not a sewage system, so we have to treat that mud that is polluted.
Right. Actually, another question that from the participant is when you operate the barrier more frequently as the sea level rises, what kind of ecological impact to the Venice Lagoon you foresee?
You have to consider that in Venice, you have a nip tide and spring tide. When there is nip tide, you have at least 6, 8 days a month in which the tidal range is reduced to just plus minus 10 centimeters, so nothing for more than 8 hours. So these are summer closures, because this can happen not only in winter, but also in July, August. So the impact of the closure is negligible. Of course, you can consider that operating the barrier will attract different species in ecological terms. So in terms of water quality, there are only advantages, because you can flush the lagoon if there is stagnation due to a closure that by chance happens in July with high temperature. But usually the closure happens in the stormy weather. This means that the water is well oxygenated and redistributed, and the lagoon is flushed by the wind that is inducing a residual current in the system. So, generally speaking, we have two main considerations. One is related to the number of hours of stagnation that are negligible, because Venice is experimenting a natural barrier that is the tidal energy that is modulated at the nip tide. Second, we have the effect of the wind and the low temperature that is correlated with, of course, with the storm. And if happens stagnation in summer, for instance, inside the city, it is enough. We have demonstrated with a model that was asked by Walter Munk, that died last year at the age of 101. He was a very close friend of mine and visited Venice many times. He used to say, "Let the moon sweep the lagoon." And now with the barrier, we can do that.
Okay. I asked Denise if we can have an additional 5 minutes for questions that I see they are coming in a very rapid way. So another
Yes, sure.
Oh, thank you. Giovanni, I would like you to spend a couple words on the operating and control system of the MOSE project. That is a very important part of the project itself.
Yes, I want to stress that our solution is the result of the ice storm meeting we had over the last 10 years. And we made a full tree analysis to study what was the main safe way to build the barrier and operate it. And it ended out that human error is very important, but also the variability of environmental conditions are very important. And you cannot foresee all of them. Nobody could foresee the impact of COVID, for instance. So with this in mind, we made the best from the machine and from the human. So the system is fully automated, but is supervised by humans. So the machine is proposing the operation, and this operation are confirmed by an expert that is there to supervise the operation. Also, the people is there to assist the machine in case of a failure of a valve or a component. and the machine says, please open that valve because I checked it's closed. And so there are two possibilities. The monitoring system is wrong or the valve has been clogged. In this case, you need the human. The machine is not able to solve this. Rotterdam instead took another attitude, not now. This happened 20 years ago. They decided that the human error is so big, the failure, after, we were after Chernobyl, after Long Mile Island. So the Atomic Agency and other agency that consulted the Dutch engineers said, human error is terrible. You have to avoid human interference. So do Rotterdam Barrier completely automated. And this was done completely automated. You do nothing. The machine goes by itself most of the time. And then what happened? At a certain point, the situation, the environmental condition, the modification in the component, the electronic equipment, so the aging of the system was so quick that instead of having a reliability on demand of 1 over 10,000, the reliability was 1 over 10.
Huh.
Because the local expertise disappeared. Nobody were able to take peace with equipment because they shifted from an internal governance to bidding, and then they lost a lot of knowledge. And so the new upcoming company that won the competition for the maintenance refused to operate the barrier based on the manual and asked more money to test again the barrier as if it went from moon, not trusting the paper indeed. So this is a big lesson that stress the importance of keeping the local knowledge in place independently from the economical reasons, because if you lose that, you can go into very, very big trouble. That's why I invite you that are listening to me to sign my petition to reinstall in Venice the historical authority instead of bringing one new that will forget all the knowledge that was accumulated over the last 30 years.
Giovanni, well, last question, if I may ask you, is of course a project like this, involve, the citizen in their daily life and so on. And so how the Venice, Resilience Lab helps, in keeping informed, involve the citizens, of Venice in with this MOSE project?
Essentially, what we do is exploration. We do magnificent exploration of how nature is working in the lagoon with the young student, with pensioner, and we monitor the impact of the closure. For instance, yesterday I measured the velocity and the propagation of the differential closure all over the lagoon. We have installed the rod and they can take a picture of the rod, send the rod to me. Immediately I prepare the report. And if you go to my Facebook, you can see the impact of the operation that was made by the citizen. So this is called citizen science, not just for the sake of curiosity, but to help people to practice adaptive co-management. So if we learn together, we are able to speak up and ask what we need and get it, because we are also able to do concept proposal. In this way, we can trigger the money from the top to come down and fulfill the need of the people. At the same time, the people can bring a consensus in a democratic way to the governor, and then we can interconnect not only the citizen among themselves, connected to the pleasure of living in a beautiful city and a beautiful lagoon. And this is a socio-ecological interconnectivity but also a social connectivity when we deal with the policy and the governance.
Well, thank you very much, Giovanni. With this, I mean, last, I mean, consideration that very, very, very important, the involvement of the citizens should be in a project like this. I would like to thank you, the Bay Atlantic, I mean, University and the Global Policy Institute, Paolo von Schirach, and thank you very much, Giovanni. And probably in the next, I mean, a few weeks, we're going to present other situation, other projects around the world that, I mean, involve the protection of the certain coastal area due to the climate change. So thank you very much for all of the participants to this event, and have a good day. Thank you.
Thank you. Thank you.
Thank you.